Welcome back to Python for Scientific Computing 1. They say a picture is worth 1,000 words. You could argue that the same holds true for numbers as well. It's a lot easier to look at a chart or a plot than to look at an array of numbers if we were to interpret or make sense of that data. There are several excellent libraries in Python that have been developed for this purpose. I'm going to talk about one such library, namely the Matplotlib. Data visualization is an integral part of any scientific computing endeavors. Throughout a scientific computing project, we use visualization for many purposes. Initially, visualization is made use for exploratory data analysis to look and understand our data. And we saw that the pandas provides us with certain tools to perform this task. Once we perform our analysis, we want to make some quick and dirty plots to understand what is being predicted, how good are our forecasts, or how good are our predictions and such. This is part of the analysis where we are trying to make sense of the data. And finally, when we have interpreted the data, performed all the analysis, we want to report our results or communicate our results. For that, we have to make graphs and charts that not only communicate the information that we want to communicate, but do so to a person who is not as intimately involved with data analysis as we are. So it should have all the relevant information on the chart so that any layperson can make sense of what is being presented. So visualization tools that you're going to use for these purposes can vary widely. Nonetheless, our focus here is on that last step where we want to create scientific plot to communicate our results. Native Python, unfortunately, doesn't have any built-in visualization tools. There are many libraries that come to our rescue, and in particular, the Matplotlib is one very versatile library that is used widely for analysis and interpretation and communication of scientific data. Of course, visualizations do vary by the media. For example, how you're going to visualize in a scientific journal or in a scientific publication is going to be very different from how you're going to present visualizations, say, on a web page. So there are different libraries for different purposes. Since this is a scientific computing class, it's focused on visualization of data for scientific purposes, and Matplotlib clearly is a very good library for making these plots or performing these types of tasks. If you want to learn more about the Matplotlib library, I encourage you to go to matplotlib.org, where they provide you with several examples and use cases that you can see how Matplotlib library can be used. You can make a wide range of plots, scatter plots, statistical distributions. What's really nice about Matplotlib is that it integrates very well with data structures of NumPy and Pandas, as well as those in native Python. So whether your analysis has been carried out in native Python or you've made use of other numerical tools such as the numerical Python library or the Pandas library to read in data, you can work seamlessly with the Matplotlib library. Before we jump in and see how to write code and what is the syntax for making plots in Matplotlib library, let's quickly refresh what are the various elements of a figure. Here I show a simple chart, and you can see that the chart is made up of y-axis and x-axis. It's got some points. Very likely these points are observations that we have obtained from some experiment. And then there are lines. These are some other pieces of information that we have either obtained or generated using some analysis. And we want to visualize all of this. Of course, we need to communicate to the viewer of this chart what that blue line means, what the orange line means. And for that, we are going to put a legend. Also, we have to make sure our axes are labeled correctly, both the x-axis and the y-axis, so that they tell you what's being plotted on which axis. We make use of the major tick marks, the minor tick marks, and also the tick labels to make sure that people are able to extract information that's in this graph. Every graph also has a title that explains what this graph is all about. So you can see that as even a simple chart, a two-dimensional scatter plot, is going to have a variety of different elements that need to be specified and manipulated. What Matplotlib library does is it allows you to control every element in this figure or the chart. The Pyplot module is part of the Matplotlib ecosystem. system. Pyplot is what provides a lot of flexibility for creating and controlling elements of a plot. Pyplot module of Matplotlib provides us with a set of functions to easily create and control plots, and it gives us two styles or two approaches to make plots. The implicit style is used for simple plots, and in the implicit style, a lot of control is given to Matplotlib, and there is very little user interaction. That doesn't mean that you can't control the major element plot. You still can. It's just that for by and large, a lot of work is happening inside. On the other hand, the explicit or the object-oriented approach is more suitable for plots where you want a finer control on the various elements that go into that chart. Let me start off with implicit plotting. Implicit plotting is useful for making simple plots, and especially if you're just making a single plot, this is really the de facto method to go to. With implicit plotting, you can plot histograms, bar plots, scatter plots, box plots, line plots, and others. The key element is to import the Pyplot module from Matplotlib, and we usually do that with an alias of PLT. All the functions or methods of implicit plotting have the PLT prefix followed by the method that you're calling. For example, if I say plt.plot, it's going to make a plot for me. If I want to add an X label, I say plt.xlabel, and in quotations, I supply what that X label should be labeled as. I can add a grid, I can add a title, I can add legend. Let me show you how the implicit method works by plotting a histogram. So to do that, first I have to bring in some data. I'm going to import OS, which is the operating system library, and then I'm going to import pandas. I'm going to be using pandas to read a CSV file and then take the contents of that CSV file and make my plots. So with import OS, I first define the path. This path tells me where the working directory or sets the working directory and tells me that all the files that Python needs to have for this code is present in that folder. Then what I do is I put os.chdr path. So I change the directory to that working directory that is specified by the path. And if I want to know what the current working directory is, I make use of os.getcwd, which gives me the current working directory. Once I'm convinced that I'm in the right working directory, then I define the file name. Here I'm defining the file name concrete-string-data.csv. This is the same data set that we downloaded from Kaggle in our pandas lecture or video. And once I have this CSV file, I can use panda pd.read_csv. Note again, pd is the alias for pandas, and then read_csv helps me read that file of that file name. If I do a.head, it is showing me the top 5 rows of that object A. And I want to create a histogram for the concrete strength. To do that, I'll first extract strength as an array, and I do that by saying np.array. This is numpy.array, a.strength. A.strength is object A is a pandas object, and strength is one of the columns in that. Be careful with capitalization because Python is case sensitive. And then once I have defined the strength object as a numpy array, I do plt.hist, which is plot.hist strength, and it plots me the histogram. I put plt.title, and then I say distribution of concrete strength because it is telling how my concrete strength is distributed. I can add an X label, which says the strength is in million pascals or megapascals, so I have MPa. And then on the Y label, it tells me how many samples fall within that bin, how many samples have a strength less than 10 MPa, how many have strength between 10 and 20, so on and so forth. And then finally, if I say plt.show, I am telling the plot to plot it on my console, which is my computer screen. When you make histograms, you can see that there are several other aspects that I can include that I have not included here. If I want to make a scatter plot, then I need two attributes, one to go on the x-axis and one to go on the y-axis. And so I extract again two elements. I extract cement, for example, the amount of cement as an NP array, a.cement component, and then I extract the strength as np.array a.strength. And then what I do is I make a plt.plot, which makes me a scatter plot, cement going on the x-axis and the strength going on the y-axis. And this M plus tells me that I want a magenta color uh, plot symbol with plus. Again, I use plt.x label to put my label, x-axis label, plt.y label to put my y-axis label. I put a title, I put a grid, and then eventually I say plt.show to show the plot on the console. There are several markers that you can use. I've provided a sequence here. Of course, you can go to your web browser or to Matplotlib website and search for these markers. Similarly, I can use different numbers or letters to put different colors that I want for my plot. The object-oriented plotting is another way to make plots in Python and using Matplotlib. And object-oriented plotting offers better control and helps us make different layouts of plots. For example, I want to make a 2x2 plot or a 3x3 plot, which is very popular in scientific literature, then I can make use of this object-oriented plot. Object-oriented plotting uses two objects, the fig and the axis. The overall plotting space is controlled by the figure object, whereas the individual plot is controlled by the axis object. And axis objects are denoted by IJ notation. I stands for rows and J stands for column. You can mix different types of plots in each of these panels. For example, you could have a scatter plot, a histogram, a violin plot, and a box plot as part of your 2x2 plotting space. You can also make use of zipping, zip function, to loop through these panels and place your plots appropriately. So let me show you an example of this. What I want to do is I want to plot cement. So I'm bringing the cement as a dot cement component. I'm bringing coarse aggregates as a dot coarse aggregate component. I'm going to bring fine as a dot fine aggregate component, water as a water component, strength as a dot strength. So I have these 1, 2, 3, 4, 5 values or arrays, numpy arrays that I want to plot against each other. To do that, I'm going to create fig axis, and I'm going to create two objects, fig and axis for axis. And I say it is plot.subplot. So here I'm making subplot, and I'm making a grid of 2x2, which means I have 2 rows and 2 columns. My rows are labeled 0, 0, 1, 1. The first row is 0. This is 0 row, and then this is also 0 row, first row, and first row. Similarly, my columns, this is 0 columns, and this is 1 column. So I have them as a list of 0, 1, 0, 1. My X values are going to be cement, coarse aggregate, fine aggregate, and water. So I have a cement, coarse, fine, and water, which correspond to these 4 variables that I just created as numpy arrays. My labels are going to be plus magenta. I'm going to put 2 green. The 2 stands for this triangular shape object. And then I'm going to put red stars, and then I'm going to put blue squares. So I have these 4 labels. XLab is going to be labeled cement, coarse aggregate, fine aggregate, and water. And then I have initialized an index to be 0. And then I say for IJ and zip of row dot column. So zip of row dot column means it takes 0, 0, 0, 1, 1, 0, 1, 1, and then it kind of uses those elements for IJ. It parses it and then reads it. And then it says that axis IJ dot plot x of IDX, x will be 0, plotting the strength because my strength is always the same for my y-axis. So I'm just going to keep it as strength. And then my label of IDX, which will be plus M, 2G, or whatever symbol I want to use. And then I'm going to put set x underscore label. See, the set underscore x label is associated with this particular axis, each of these axes. So each of these axes are going to get a different label, and that labels are read from this XLab using the index. This is 0 index, first index, second index, and third index. And then for each of these axes, I plot a grid that you can see is happening. And then once I do the 0, 0 element, then I update my index and then zip the next numbers, which are 0, 1, that is 0th row, first column, make this plot, and then update my index, and then zip and get 1, 0, which will be first row, 0th column. and then run through this loop, and then finally 1, 1, and run through this loop. So we set everything up on the top, what we want, and then we simply create a loop with the zip because we want to loop through rows and columns, and we can do that with a single for loop without by using this zip statement. Once the plot is done, I'm going to say plt.tight_layout. Means it's going to give a very clean presentation of these plots without overlaps. And finally, if I do plt.show, it's going to show me the plot. So in summary, native Python offers no charting or graphing capabilities, but there are several excellent libraries for visualization. Matplotlib library is widely used for scientific visualization, and it's capable of making 1D, 2D, and 3D plots of various types. Pyplot module of Matplotlib library offers two modes or two ways to make your plots. The implicit mode is the simpler mode, and it's useful for making single plots. You have functions for making plots, adding labels, adding a grid, adding a title. Object-oriented mode makes use of two objects, fig and axis. Fig controls the overall plot space, whereas the axis control individual plot space. Better control over the elements of a plot, and they're very useful for making multiple plots. Of the two, clearly the implicit method is a bit easier. I certainly encourage you to start there, but with a little bit of practice, the object-oriented approach should also become second nature to you once you understand what's going on. And finally, before closing, I'll urge you to visit the matplotlib.org website, where they have examples for several different types of plots that can be made using the Matplotlib and the Pyplot libraries. I hope you found this video useful. I will see you in a wrap up in the next video. Till then, take care and goodbye.